Okay, college accounting scholars, now that you're experts on fixed costs, variable costs, and semi-variable or mixed costs, we're now going to apply your knowledge to these particular costs, and we're going to use some of your algebra that you have learned in your previous math classes. Specifically, we're going to do some determination of slope and associate some of those particular variables, relate those specifically to cost and activity data. So let's say we do have a semi-variable or mixed cost scenario as we discussed in our last video. And again here the semi-variable or mixed cost scenario is one where over a certain range of activity, costs tend to jump because of major drivers. In the example we gave in the previous discussions was one where, let's say you start manufacturing a product in one factory, and the utility costs associated with it, the lights, for instance, are pretty much going to be the same in that particular factory, whether you manufacture 10,000 units in a week or 20,000 units. You're going to have the lights on from 8 to 5 every day, and that utility cost is pretty much going to be a fixed cost. However, that fixed cost would tend to turn into a semi-variable or mixed cost if you needed to open another factory because you're doing so well in your business. So instead of paying one utility bill for one factory, if you opened another factory, your utility costs would tend to increase, and therefore the semi-variable capability or characteristic associated with it. And this is probably a pretty good example of how that this graph at the bottom is a pretty good example of how that might occur. But anyway, so if we wanted to determine the actual fixed cost component and variable cost and total cost component, we would basically apply some algebra to this problem. So let's get some terminology down here in terms of process and variables. So the first step you would do is, in the data that you receive, very similar to the data charts that we looked at previously, you would actually look at the highest and lowest levels of activity. And activity here again is going to be called, from a variable standpoint, AL. You would also determine the total cost and at each of those various levels. So here again, the total cost at each of these various levels would be called TC. And basically you would ignore all other data. Once you do that, then you can kind of begin to describe your equation and the variables associated with that equation. You need to write these down, as we talked about. You would have a TC would refer to total cost. VC would refer to variable cost. FC would refer to fixed cost. AL would refer to activity level, and VCT would be the variable cost component of the equation. Traditionally known in algebra as the slope. So you've got those down. Now let's see how we put those particular variables to use. So to determine the variable component, you would basically use this particular formula. The VCT, or slope, equals the change in total cost versus the change in activity level. Okay, so the determination, for instance, of fixed cost, the formula would be fixed cost equals total cost minus the change, or basically the slope, which you have calculated, times the activity level. So that's a equation that you want to make sure you get in your notes. And then the determination of total cost would basically be total cost equals fixed cost plus the variable component, or VCT, times activity level. Okay, again here, make sure you've got these all in your notes. And once you've got them in your notes, please start the video again, and let's see how we can apply these particular equations to the problem. Okay, so we have here another set of data. We've got 6 data points, and the important point here is we're looking for the high-low points in the data. So if we scan the data from the activity standpoint, in the activity level column, looks like the high activity level is 15,600 units. You don't want to write this down, okay? So that's the high activity level. The high total cost associated with that is $15,800. Okay, so you got that down as well. So 15,600 and then $15,800. Okay, if we scan the data again, the low data point here is 8,300 units in terms of activity level. And the total cost associated with that is $8,500. Okay, so to apply the high-low method, we've pretty much got the data that we need. And let's do the math. So in doing the math, we would again apply the formula. The variable component is a change in total cost and change in activity level over the change in activity level. So as we determined, our high point was 15,600 in terms of units, and that had a total cost associated with it of 15,800. And the low point was 8,300 units and an associated total cost of 8,500. So we basically do the math, divide the change in total cost over the change in activity, and you can see the math down there at the bottom of this slide. And so the variable component, or slope, equals $1. Pretty straightforward. Pretty straightforward. Okay, so once we have that information, then we're in a situation where we are able to determine fixed cost. And fixed cost, as we talked about, is total cost minus the variable component times activity level. So again, we have this data. So we had $8,500 as the data point for the cost at the $8,300 unit level. We determined the VCT, variable component variable or slope, was $1. We essentially do the math, and so the fixed cost at that particular point is $200. Okay, so that's pretty cool. We kind of check our math. Our total cost equals fixed cost time plus activity level times VCT. Here again, we do the math, and son of a gun, there is the $8,500 level. Pretty cool, guys. You guys, I'm sure, are semi-experts now. I would review these last particular slides and formula several times, because you're going to be seeing questions like this on your quizzes and on your tests. So it's important that you have a good understanding of the algebra and math involved. So that being said, with the advent of computer and statistical techniques, the laboring we did in the last few slides really could be done for us through the application of a statistical technique called linear regression. You know, if you guys that have taken AP Stats, you might have been introduced to linear regression. It's pretty cool. It's pretty cool because you are basically taking the data that we're using through the last few videos, and if you put it into a Excel spreadsheet program with regression capabilities, it pretty much does all the work for you. I'm not going to spend a lot of time on this because this is a more advanced topic that really requires a background in AP Stats and as well as a good understanding of the workings of Excel, which is sort of a chapter unto itself. But I want you to make you aware that linear regression techniques can be used to solve problems like we just did in this particular video segment. So have a great night, guys. Talk to you tomorrow.